Question 12. Now this is pretty complicated, but bottom line, it's just a whole load of either Pythagoras or SOHCAHTOA. So bear with me. So find the distance BE. So that's from here to here. So we're just looking at this right angled triangle on the end, the triangle BCE. Okay, so I've done that here in blue, BCE. So fair enough, we've got the opposite side, we've got the angle, we need the hypotenuse. Basic GCSE, we get x being 200. So the length BE is 200. Now for part 2, we've got to find the angle that the path AE makes with the horizontal. So really think of the triangle AEC. That's what we're aiming towards, okay? That triangle AEC, which I've sketched down here. Always do little two-dimensional sketches to help you gather your thoughts. So in order to do ACE, I know that EC is 100. I need to build my way up to AC. Okay. Now this is going to take me a while. I'm going to be able to get AC if I consider the triangle ABC, when AC would then be the hypotenuse. But even before that, I've got to work out what BC is, because I need that for my triangle. So basically, back to the triangle that I to work out BC, okay, consider the triangle consider the triangle ABC. I know that AB is 500, and BC I can work out from this triangle I've just done. Okay, so BC is going to be 200 squared minus 100 squared, square root thereof. So BC falls out of the workings I've just done for part 1. So BC is root 30,000. So in this, here we go. So AC is the hypotenuse. So in a second lot of Pythagoras, I can do AC squared as 500 squared plus root 30,000 squared. This gives me AC being root 280,000. Note how I'm keeping it in square roots all the time, because they're exact. So I can now finally move on to my triangle ACE. I've just worked out that AC is root 280,000. I knew that CE was 100. So to work out the angle between AE and the plane, so again, people do get a bit confused about this. I know we're finding an angle between a straight line and a plane, but just take any straight line you like on that plane. So it's got to be the straight line joining up with the line itself. So it's just the triangle ACE. So anyway, the angle we need is x. So just basic SOHCAHTOA. Tan x is 100 over root 280,000. X is 10.7. Now for part 3, find the area of triangle ABE. Okay, ABE. Well, I know AB is 500. I worked out earlier on that BE is 200. Make sure that you realize that the angle ABE is a right angle, and then it's very straightforward. Area of a triangle, half times base times height, half times 500 times 200 is 50,000. Now finally it says hence find the length of BG. Now you cannot assume that AG equals GE. It doesn't. Okay, so in order to do this you have to do it via the area of the triangle, hence why they've made the question a hence. So what we do know is that the area of the triangle AEB is going to be half times base times height, which is half times AE, which I've worked out over, which I can work out, and times the height BG, which is my unknown, and the area of that triangle equals 50,000. I've just worked it out. So my area of my triangle is half times AE times BG. So we work out AE, which is just a continuation of what we did previously. So AE using Pythagoras is root 290,000. So triangle ABE is half times root 290,000 times BG, and that area is 50,000. That allows me, just by dividing by BG and dividing by this and this, to work out that BG is 185.70, 186 to 3 sig figs.